Welcome back to PV Online. Today we're going to put together everything that you've learned as far as stoichiometry, and that's going to require three different conversions. One's going to be gram to mole, the next one's going to be mole to mole, and then finally we'll go mole back to gram. So we're going to do a mass to mass stoichiometry problem. You're going to calculate the mass of an unknown value from a given mass. There will be three steps in solving our problems. The first will be doing a molar mass conversion. The second will be a mole ratio. And then the third and final step will be using the molar mass of the unknown. Now, when you solve these problems, they're going to be set up in parts A, B, and C, just like this. So make sure you write down notes. Over here in the top right, we have the molar masses of all the different elements that are present in our reactants and products. And so now let's get started. The question is, what mass of copper 2 cyanide is prepared by the reaction of 1.25 grams of copper sulfate? We have our balanced equation. So for part A, we're going to convert the given mass to moles. So take a look at which one of these substances do you know? And we know that we have 1.250 grams of copper sulfate. So the very first thing that we have to do is find the molar mass of copper sulfate. And if you add them up on your calculator right now, you will get 159.62 grams of copper sulfate is the 1 mole of copper sulfate. That means that we can eliminate this guy completely. Now we have these two mole ratios, and we have to choose wisely as far as which one we're going to use. I've got 1.250 grams. I want to find out the number of moles. In order to do that, I want the grams in the denominator so it cancels out, and I want the moles in the numerator. And that's why I'm going to use this ratio. We're going to write down what's given, apply our mole ratio, and look at what we get, 0.0078311 moles of copper sulfate. So use that number. So the very first thing that we did was we found out the number of moles of the known. Now we're going to convert the moles of the copper sulfate to the moles of copper cyanide. Which one of those three ratios are you going to use? I've got moles of copper sulfate. Where's that going to go? In the numerator or denominator? It's going to go in the denominator. I want to find copper cyanide. Copper cyanide is over here. There's our ratio. Next thing we're going to do is calculate the moles of copper cyanide. So this is going to be part 2 in your problems. Write down what's given. That's from the last. Write down what's given, which was what you saw for in part A. Use your mole ratio. Make sure that the moles of copper sulfate cancels out. Now in this case, just because it's a 1-to-1, you still need to do this ratio. You still have to show your work. And so I'm going to produce 0.007831 moles of copper cyanide. All right, the next thing we need to do is we need to find the molar mass of copper cyanide. Using the periodic table, can you come up with that? So I get 115.59. So in each formula unit, we've got 1 copper, 2 carbons, and 2 nitrogens, giving us a total molar mass of 115.59. Now let's take a look at our ratio. We're finding the mass using the unknown's molar mass. So we know the molar mass is 115.59. Now remember, we started with 0.0078311 moles. Now which one of these is going to give us the correct answer? And if you choose either one of these, that's going to be fine. And the reason for that is because we have significant figures. And if you're in Intro to Chemistry, you don't need to worry about significant figures. So either the first or the second answer would have been sufficient. Part A in all of your problems are going to be this part right here, where you first go from grams of your known to moles of your known. Part B is always going to be converting using your mole ratio from your known to your unknown. And then last but not least is always going to be this for part C, going from moles of your unknown to grams of your unknown. Let's do one more example. And what I'd suggest you do is go ahead and pause the video and see if you can set it up before you see the answer. So this reaction is going to be between aluminum and hydrochloric acid. And this is going to produce a lot of heat, and we're also going to produce hydrogen gas when we form the aluminum chloride. All right, the very first thing that we need to do is convert the given mass to moles using the given's molar mass. Which substance was given to you? And the substance given to you is aluminum. What is the molar mass of aluminum? It's 26.98 grams per mole. Can you go from mass to moles for aluminum if you have 151 grams? First things first, we multiply this times my ratio. Why is the 26.98 grams in the denominator and the 1 mole in the numerator? All right, write down for part A, we've got 5.596 moles of aluminum. The next thing we have to do is go from moles of aluminum to moles of the unknown. Remember, our unknown is hydrogen. Which one of those three ratios will get rid of the moles of aluminum and leave us with moles of hydrogen? And the correct answer should be this one, this ratio. All right, so now do the math on this. We've got 5.5967 moles of aluminum. Convert it to moles of hydrogen. Now I'm going to be multiplying it by 3, dividing it by 2, giving me 8.3951. All right, for part C, now we want to go from moles of hydrogen to grams of hydrogen. In order to do this, we need to know the molar mass of the hydrogen. And in this case, the molar mass of hydrogen is, I've got a H2, there's 2 of them. How about that? 2.02. Every 1 mole of hydrogen has a molar mass of 2.02. Now, see if you can finish this. See if you can go from moles of hydrogen to grams of hydrogen. Did you set up your ratio this way with moles in the denominator and grams in the numerator? Leaving us with 17.0 grams of hydrogen. Again, we could do this in a multi-step, but we're going to do 3 parts for every problem. You now have some problems to work on. Good luck, and we'll see you next time.